Hello. Okay, so in this video, we're just gonna go back to the theorem that we discussed in the previous video about the chord and the radius. Okay, but this time we're gonna do the proofs to the theorems, and we're gonna look at some exemplar questions. By this I mean questions that have been in the exams before concerning these two theorems. Okay, so don't forget to follow my page on Instagram, that's Mathematics. Also, you can drop me a quick email if you want to collaborate, or you've got like inquiries about tutoring and math help and anything else. You can reach me in my email. Don't forget to like this video. If you find it very helpful, then please like the video. And if you find all these other videos helpful, please subscribe to this channel and click on the notification to get notifications of any new videos that I'm going to be posting on here. Okay, so let's get straight into it. Okay, so in the previous video, we did learn about this theorem. And in the theorem, we drew our circles and we found out this, that if we draw a line from the center of the circle to a chord at an angle of 90 degrees, it's going to divide this into two equal parts. Okay, so that's what we learned in the previous video. Now, we are now going to prove this. So we are now going to do the proof, and this proof is examinable, so which means it can be asked for in the final metric examination. Okay, so now the question now is, how do we do this proof? All right, so let's just call this point A, let's call that point B, let's call that point M, and let's call that point O. Okay, let's give names to those points. Right, let's also do something like this. All right, I'm gonna draw a line that is joining the point O and the point B, which is on the circumference. Okay, and I'm gonna draw another line from the point O to the point A on the circumference. Okay, why did I draw these lines? Because I think by now we know a line that is going from the center of the circle to any point of the circumference, what do we call that? It's a radius, isn't it? So this OB is a radius, and the line from the center O to the circumference at A is also a radius. Okay, now what do we know about the circle? What we know about the circle is that the radius is always the same, it never changes. So if the radius is always the same and never changes, what does that mean? Well, that means that OA, which is this line there, is the same length as OB. Okay, and the reason for that is just what you said already. These are equal radii. Okay, right, so that's the first thing that we know there. Okay, what else do we know? Well, what we do know is that this line OM is the line for this triangle and that triangle. Basically, what are we trying to say here? So can you see that by drawing this radii and that radii, we've got two triangles there. Okay, so we've got the first triangle there, all right, BOM, and we've got the other triangle AOM. Okay, right. So what we're trying to do there is to try and prove that this triangle AOM and this triangle BOM are congruent to each other. Okay, if you have forgotten the concept of congruency, there is a video that I'm going to be uploading later on explaining congruency. Otherwise, you can just hit me on the comment section, or hit me on my DM me on my Instagram, and I can give you a full explanation of that, and we can talk about tutoring and all that. All right, so we just found that OA and OB are the same because the radii is equal. Right, now what were we trying to do actually? Actually, we were trying to prove that the triangle AOM is supposed to be congruent to the triangle BOM. Okay, so which triangle? Well, this triangle AOM, this one there, right? This one should be congruent to the triangle BOM, which is that one there. Okay, so we've already found out that this side of the triangle OA of the first triangle and this side OB of the other triangle is equal to each other. What else can we see there? Well, we can also see that OM is a side for triangle BOM. OM is also a side for triangle AOM. Okay, so what are we going to write? Well, we're going to write that OM is common, which means is the same side between two triangles. So obviously those corresponding sides is equal. Now, what is the third thing that we can see? Well, we did draw this at an angle of 90 degrees, isn't it? So what that means is that this angle BMO, right, is equal to 90 degrees. Now what happens? Remember, the straight line is supplementary angles. So what that means is that angle AMO is supposed to be also equal to 90 degrees. So angle AMO is also equal to 90 degrees. So what does that mean? That means angle BMO and angle AMO are equal. Okay, right? Well, if you want a reason, these are supplementary angles. Okay, you can write these as angles. Okay, so can you see something? These sides is equal, that side is common, those angles is equal. So what that means is that the triangle AOM, that's one, and the triangle BOM, that one, are going to be congruent to each other by the SSA condition. Remember, SSA, sides is equal, angles is equal. Okay, so if they are congruent by the SSA condition, what does that mean? Well, then that automatically means that the side BM, therefore, of the triangle and the other side AM of the triangle is also equal. Okay, so that means AM is equal to BM. And there we have it. We have proved this theorem. Okay, now the converse of the theorem is that the perpendicular bisector of a chord passes through the center. Okay, now we are going to prove this theorem as well. Okay, so here's the proof. All right. Okay, so how are we going to prove this theorem? All right, so let's say we just draw any line. Okay, let's just draw any line. Actually, I'm just gonna remove that center and pretend we don't know the center. Okay, so we want to draw a line that's obviously going to bisect this into two equal parts. So it's just going to be some line. Okay, all right, let's give names to this. Okay, so let's call that point A, let's call that point B, and okay, and let's call that point C. Okay, so let's call this point M. Okay, right, so we are drawing a perpendicular bisector, which means this angle is going to be a 90 degrees. Okay, so first of all, we're just gonna assume that O, okay, so let's draw another point O, right? And let's say this O is the center, all right? So assume that O is not the center, is not the center of the circle, okay, of the circle. All right, so if O is not the center of the circle, then where is the center? That's what we're trying to look at here. Okay, now what we do know is that this angle here, AMC, all right, so that angle AMC is equal to 90 degrees. Well, we drew it at 90 degrees, right? Okay, so if this AMC is equal to 90 degrees, then what that means is that BMC should be also equal to 90 degrees. Okay, what about this point O? Okay, so let's draw that angle. Right, so let's just draw that quickly. Okay, before I go to angle O, what we've just agreeing here is the fact that angle AMC plus angle BMC will then become 180 degrees. Why? Well, they are supplementary adjacent angles. Okay, so they are supplementary adjacent angles. So that's why they add up to 180. But now if we now say AMC, that angle here, plus BMC, now if you try to add an angle OMC, that is definitely not going to be equal to 180 degrees, okay? Because now that's, and we know that's not possible. Can you do that? No, we can't do that. So this actually forces us to then say, therefore, that the line MC then passes through the center. Through the center. Okay. This proof, however, is not examinable in the grade core final exam. Okay, so it's just a proof that you can just learn, or maybe if it's in your syllabus examinable, then that'll be the proof. Okay, so I'm just gonna quickly show you how we're gonna use these theorems, and to do that I'm gonna just take some questions that have been asked in final exams before. This was a question that appeared in the mathematics South African mathematics paper 2 NSC exam. That was for the February to March exam session in 2015. Okay, so the question was something like this. It was question 7 in that particular exam. Okay, so now it's very important that when you approach exam questions in Euclidean geometry, you make sure you read and understand and interpret the instructions. Very, very, very important. Okay, now let's understand what this question is saying. So in this diagram, AB is a chord. Okay, so we see AB is a chord there of a circle with the center, or so we told that's the center. We know that's the center. M is the midpoint of AB. Okay, so that means this point M is dividing these into two equal parts. MO, all right, this line is produced to P, where P is a point on the circle. So P is a point on the circle. Right, what else are we told? OM is equal to X units. AB is equal to 20 units. Okay, so what does that mean when you say AB is equal to 20 units? It means this whole line here from A to B, that whole line there is equal to 20. Okay, so that's what that means, right? And then PM, or the ratio of PM to OM, right, is 5 is to 2. So what does that tell us? That tells me that if this whole P has got a ratio of 5, it means, okay, or let's call it 5K and use a different variable. It means OM, which is that part here, is going to be 2K. Okay, right. So that's the information that we have on our question. It's very important that you do these markings. And the nice thing about the exam is they give you an answer book with the diagram. So you make these markings on your diagram already. Okay, first question. Question 7.1. What is the length of MB? Well, easy, right? Remember, the soul is 20 divided into two equal parts. So MB is equal to 10. Okay, so MB, all right, so let me just write 7.1. MB is equal to 10 units, right? Okay, so that means this is 10 and that's also 10. All right, do we have to give any reason? Oh yes, we have to. It's geometry, so you are actually required to give every reason for every answer that you write down. Okay, so what's the reason of this for this answer? Well, we are told in the question that M is the midpoint of AB. That's the reason. Okay, M is the midpoint of AB. Okay. All right. So let's see. What's the next question? Give a reason why OM will be perpendicular to AB. Oh, our theorem. Remember what you said about our theorem? A perpendicular bisector of a chord passes through the center. Okay. And what other theorem did he have? The first theorem that he had is that if you draw a line from OM at an angle of 90 degrees, it divides the line into two equal parts. Okay, so you're just gonna write down the theorem. All right, and we don't have to write like the whole full statement, because sometimes this is the exam, you don't have enough time to write everything. Okay, all right, so the reason there is because, okay, so 7.2, give a reason why MO is perpendicular to AB. Well, we just learned in our theorem that a line from a center of a circle to a midpoint of a circle is perpendicular. So you're just going to write it in short. Line from center to midpoint of chord. Okay, line from center to midpoint of chord. What about it? Well, it is perpendicular to, okay, you can use this as a sign, perpendicular to chord. Okay, that's the theorem we learned about, isn't it? So that's why this would become 90 degrees. And if this is 90 degrees, that's also 90 degrees. Okay, next question. Now we must show that OP is equal to 3x over 2 units. Okay, to do that, we're just gonna say something. Okay, what is the ratio of PM to OM? Okay, here we have it. Remember we said 5k over 2k. Yeah, I can just cancel the k's out if you want to. Okay, now what are they asking for? So if this is 5k to 2k, well, to get 5k, what happens is 2k plus another 3k. Okay, so another 3k plus 2k gives us 5k. So now what do we know? Well, we also know that the ratio of OP to OM is gonna be what? 3k over 2k. Okay, you can cancel out the k's. It's fine. All right. Now, what else do we know about this? Okay, we don't know what OP is. All right, so we don't really know that, but we do know that OM is equal to x. This x there. Okay, so now all we're just going to do is solve this for x. So which then means if I cross multiply this x both sides, cross multiply both sides, that means OP is going to be equal to, remember this cross multiplied, so that's 3x over 2. Remember it cross multiplied, so that disappears. Okay, so OP is equal to 3x over 2. Okay, now on question 7.4, we're supposed to now find the value of this x there. What is that x equal to? Well, we just found out previously that OP is equal to 3x over 2. Now, what do we know? Well, if I add OP and OM, I'm supposed to get a whole total of 5, right? So what I know is that OP plus OM should give me a whole total of 5, which is the total ratio there. Okay, now, what is it that we know about OP? Well, OP, we just found out that this is 3x over 2. Okay, what do you know about OM? Well, OM, we know that is x, which is equal to 5. So this is just a very simple equation that we're just going to solve here. All right. Well, how do we solve equations with fractions? There's many ways to do that. Okay, my preferred method is to just multiply everything by the least common denominator of 2. Okay, so just multiply everything there by the least common denominator. These kind of cancel out. So 3x plus x times 2 is 2x, which is equal to 5 times 2, which is 10. Okay, 3x plus 2x, we know that's like terms. So it's going to be 5x, which is equal to 10. Okay, divide both sides by 5 and x equal to 2. There you have it. Okay, so that is just one way in which we are going to be using these theorems. Oh, and let me just say that is one way in which they are going to test you for this theorem. Okay, okay, so here's another example of how you can be examined for this theorem that we've just learned. Okay, so this is a question from the November paper 2 exam of the year 2016. This is the South African National Curriculum Statement. Okay, so let's see how we are going to be approaching this question. So as we said before, that if you have this question, it's very important that you take note of all the information that is in that question and kind of plot it onto your diagram because you're going to need it, right? Now I kind of drew my own diagram. It's one that I can like write things on, but you don't have to do that because you're going to be given an answer book with all the diagrams that you need. Right, so let's see how we answer this one. So A, B, and C are points on the circle having the center O. So now we know the O is the center. Okay. S and T are points on ACs and AB respectively, such that OS, this line here, is perpendicular to AC and OT is perpendicular to that. Okay, what else do we know? We know that the whole distance of AB is 40. Okay, so this part here to that part there, this is 40. And AC is 48, so from A, this part here, to C, that part there is 48. Okay, right, that's the information that we've been given. Now we're going to use that information to answer the questions that follow. Okay, so let's look at the first question. We are required to calculate the distance AT. Okay, or AT is here. This is perpendicular. We know a certain theorem, right? We talked about the theorem before that a line that is perpendicular to a chord from the center bisects the chord, right? We did talk about that. So we're just gonna give the answer to that. Okay, so it's quite simple. AT therefore will be just equal to 40 divided by 2, which is 10 units. Okay, all right. Now what is the reason for that? Well, because the line from the center of a circle perpendicular to a chord bisects the chord. So this is the reason that you're gonna write is simply that the line from center is perpendicular to chord, is perpendicular to chord. Okay, so that's going to be the answer to that first question. Okay, the next question. If OS is equal to 7 over 15 to OT, okay, so the radius of OS to OT is 7 over 15. Calculate the radius OA of the circle. Okay, so we are supposed to find that. Now, what are we told? Okay, let's just rearrange this ratio quickly. Okay, so OS over OT. Okay, so if I bring that OT down, it will be 7 over 15. Okay, so what that means is that OS is 7 times a certain K will be OT will be 15 times the same K. All right, so it will be kind of the same, right? So maybe we might want to write it like that. I don't know, or write it like this. It's fine. Okay, So what we do know, however, is that this was 10. We found this before, right? And we also found that, okay, that's 48. If we divide it by 2, it's 24. Oh, all right. Now, we're going to mention that, okay? We're going to mention the fact that AS is going to be equal to 24. The reason being because the line from center, so the line from center to chord, from center to chord. So okay, so that's the reason why that is 24. All right, now we're going to use our theorem of Pythagoras. Okay, so that's what we're going to use there. Theorem of Pythagoras, right? Well, we know the theorem of Pythagoras, right? The hypotenuse c squared is equal to the side squared plus the other side squared. Now, if we look here, OA is our hypotenuse of this triangle. Well, hypotenuse of that triangle as well. Okay, so what do we know? Well, if we use the theorem of Pythagoras, we know that OA squared is going to become equal to AS. Well, we know that's 24 square that plus the 7k square that. Okay, well, if we use this other triangle, we're also going to find out that OA squared is going to be equal to this 10 here. Oh, sorry, that's not 10, that is 20. So 20 squared plus 15k squared. Okay, so that's what's going to happen there. Now, what can we also say as a result of that? Well, this is what you can also say. The fact that this is equal to OA squared, that's equal to OA squared. So what that means is that 24 squared plus, okay, let's square this out already, 49k squared should give me the same answer as 20 squared plus, you can square that out already, that will be 225k squared. Okay, let's solve this for k, right? So if we solve this for k, what that means is that 225k squared minus 49k squared should be the same as 24 squared minus 20 squared. Okay, all right. If we do this on the calculator, we are going to find out that we get 176. If we do that by the calculator, then we're gonna get 176k squared. Okay, if we solve for k squared, okay, so divide 176 both sides, that means k squared will be equal to positive 1. Remember, we're dealing with sides of a triangle, so they can't be negative, so it's obviously just positive 1. Okay, so what that means is that k then is equal to 1. All right, so if k is equal to 1, what does that mean? Well, what that means is that OS is equal to 7 and OT is equal to 15. Okay, now that we know that OS is just 7 and OT is just 15, well, we can use any of these two triangles, incorporate Pythagoras theorem, and we get the length of OA. Okay, so let's do that quickly. So OA becomes now equal to square root. Remember Pythagoras, the squared plus that squared. Okay, I'm going to take that one. 20 squared plus 15 squared. Okay, and if that is done on the calculator, okay, I'm just going to bring a calculator on here real quick. Right, so the square root of 20 squared plus 15 squared. Okay, so that's 25. Okay, so what that tells us is that OA is equal to 25 units, and there we got it. Okay, So if you found this video helpful, or if you really enjoyed what you've been explaining in there, then please don't forget to follow me on Instagram. That's my handle. And you can drop me a quick email if maybe you want tutoring or help with your maths. And if you found this helpful, please like this video, please subscribe to my channel, and click on the notifications so that you can know when I put new content on this. So thank you for watching, and I'll see you next time. Cheers.